This is brought to you by the Alumni Association of PISJ-ES.
Let's see. There is this person, and he jumps off, let's say, a plane. He jumps off a plane. Now, his weight, there are two forces acting on this person. One is the weight of this person, and the other is the air resistance of this person. Let's say he has a parachute in his backpack. So he has a parachute in his backpack. And the total weight of the person plus the parachute is, let's say, or the mass, I'm talking about the mass. The mass of the person plus the parachute, let's say, is 80 kilograms. Okay? And since this guy is on Earth, we can simply find out the weight of this person, which is W is equals to mg. So the weight of this person would be 80 times 10, where the gravitational acceleration on Earth is 10 meters per second square. So weight would be 800 newtons. So this weight is 800 newtons. Now what happens when he hasn't opened the parachute? When he jumps off the airplane, he just goes down and down. He just goes on accelerating. Why? My first question is, why does he accelerate? That is because the air resistance acting on this person is very small. It's like if the weight is 800, the air resistance would be around 50 newtons. That is what happens. And the resultant force then is 800 obviously in the downward direction, because this is greater. 800 minus 50 newton, the resultant force is 750 newtons. So obviously, since there is a resultant force, he keeps on accelerating downwards. But what happens when he opens his parachute? When something like this happens, let's say this is the guy and this is his parachute. What happens when he opens the parachute? When he opens the parachute, the surface area of the surface area that is being exposed to air increases. Just see this. That is the reason why it is made like this. Because the surface area here, the air particles only had this space to attack. But now the air particles there are more air particles. So what happens is that the magnitude of air resistance, the weight is still the same. In this case, the weight is still 800 newtons. But the magnitude of air resistance increases because there are more particles that are pushing it towards the top. So the air resistance now, let's say the air resistance becomes around 700 newtons. Now let's find out the resultant force. The resultant force would be 800 minus 700, still in this direction, but it would be 100 newtons. Comparatively, while here it was 750 newtons and here it was 100 newtons, the acceleration here would be less compared to this acceleration, which would be far more than the acceleration here. So what happens is the speed suddenly decreases and you come on at a safe speed towards the ground. But if you just fall directly without opening the parachute, the acceleration would be a lot and the speed of impact would be a lot. So that is why you will get probably killed if you jump like this without a parachute. But if you open a parachute, the acceleration decreases because the air resistance increases because of the surface area that is exposed to the air now. Now let's see one more situation here. It is the same thing, but I'm just taking this a little bit further. Let's say the guy is wearing the parachute. This is his parachute. Let's say he is still wearing this parachute. His weight is 800 newtons. And there is an air resistance acting here. But eventually, because of increasing velocity, because he's accelerating, there will be a point the air resistance will keep increasing, because we know from we have just learned that increase in velocity causes an increase in air resistance. So earlier when he just opened the parachute, it was 700 newtons, the air resistance. But with the increase in velocity, because he was still accelerating, because of the increase in velocity, the air resistance would increase and finally would come to a value equal to the weight. This would happen. What is this? What is this scenario? This scenario is a balanced force scenario. What is happening? Let's see. Let's find out the resultant force. Minus 800 plus 800. 0. The air resistance or the upward force equals the downward force. So the net force is 0. And obviously when the net force is 0, the acceleration becomes 0. And we know that when the acceleration becomes 0, either the person is moving at a constant velocity or he is at rest. In this case, obviously, since you know that he is falling from the top of a cliff, so he is not at rest. That means he is at a constant velocity. This constant velocity at which or where, let's say where or when would be better, when the air resistance equals the weight or the upward force equals downward force. This constant velocity is also called, he would be moving with a constant velocity downwards, and this velocity would not increase since there is no acceleration. It would be a constant velocity. This is known as terminal velocity. So whenever there is a situation that the air resistance becomes equal to the weight, there is a situation of terminal velocity, that the person is not accelerating anymore, or the object is not accelerating anymore, and it is just moving at a constant velocity. And if you take a reasonable height like 1,000 meters and you throw an object from there will be sufficient air resistance at one point that it will balance the weight of that object. If it has if it has a reasonable surface area, it will balance the weight of the object, and the velocity would become constant at that point, because the acceleration or the net force becomes 0, thereby making the acceleration 0, and so it comes to a constant velocity. That situation is known as terminal velocity of the object.